how to find out square root of any real number on number line geometrically. Earlier, we have seen that if we want to find out square root of a natural number n, we must know square root of n minus 1. Let's take an example. Say we want to find out square root 10 on the number line. In order for us to do that, earlier we have seen we must know square root of n minus 1, or in this case 10 minus 1, that is 9. So if we know on the number line where is square root 9, then we can easily find out square root 10. But what if we were to ask find square root 15 on the number line? How are we going to solve this? Well, if we look at this approach, then in order to find out where square root 15 is on the number line, we need to find out square root 14 first, n minus 1. Now, how are we going to find out square root 14? Well, for that, we need to know where is square root 13, which is 14 minus 1. How are we going to find out square root 13? We have to go back to square root 12. And again, to find out square root 12, we need to know where is square root 11. And we have to keep going back. So square root 11 will mean we need square root 10, and square root 10 will mean where is square root 9. Now at this point, we know that square root 9 equals 3 on the number line. Why? Well, simply because 3 square equals 9. So if we do a square root 9, we will get 3, right? So we know if we draw a number line, square root 9 is 3. So now we are going to go backwards. So we know square root 9, then we can find out square root 10, and then square root 11, so on and so forth. And finally, we are going to be able to find out where is square root 15. So as you can understand, this is a very big roundabout way of finding out the square root of rational numbers. So in this particular video, we are going to learn geometrically how we can directly find out the square root 15. Since this method is a geometric solution, so we are going to draw some very simple geometric construction as we solve these questions. So let's take our first example. Say we want to find out, let's say square root, well, why don't we take square root 15? So how are we going to find square root 15 geometrically? This is what we are going to do. First, we are going to draw a line AB such that AB is equal to 15 units. So the length AB is 15. Next, we are going to extend AB to a point C such that BC equals 1 unit. That means the length BC is equal to 1. So again, AB is 15, right? So this AB is 15 because we are trying to find out square root of 15, and BC is 1. Next, we are going to find out the midpoint of the entire line AC. O is the midpoint of the entire line AC. So what is AC? Let's write over here. So AC is simply AC is AB plus BC, right? So AC is just AB plus BC. Now what is AB? AB is 15. And what is BC? BC is 1. So total length of AC is 16. Now O is the midpoint of the line AC. So this length is equal to OC, right? So in other words, if we were to find out the value of OA or OC, they are both same. It will be AC divided by 2. Or in this particular example, 16 by 2, or it will be simply 8. Now this is the next step. Now we are going to draw a semicircle taking O as the center. O is the midpoint. So we will take O as the center and OA or OC as the radius. We are going to draw a semicircle, something like this. It will look like this. Now you may be wondering, why did we draw the semicircle? And now this will be our last and final step. Now at point B, we are going to draw a line which is going to be perpendicular to AC. And that line, so this line will be basically a line going through point B, which will be perpendicular to the line AC. And that line will intersect our semicircle. So we will get a point, let's call it point D. So BD is such a line which is perpendicular to the line AC through point B. And this intersects the semicircle that we had drawn. So now you will be surprised to know that this length BD is square root 15. In other words, the measure of the length BD, if you were to measure this length is going to be square root of 15. So we did not know what is the actual length or how much is square root 15. So using this geometric method, now we have found out what is the measure square root 15. So let's write down these steps one by one. Say we want to find out square root of any real number x. So first we draw the line AB such that AB is x units. Next, we extend the line AB to a point C such that BC, this length, is 1 unit. After that, we take midpoint of the entire line AC and call it O. Then taking O as center and OC or OA as radius, we draw a semicircle. Our semicircle looks something like this. After that, we draw a line perpendicular, passing a line perpendicular to AC, which is passing through point B. And that line cuts our semicircle at, let's say, point D. So this angle is 90 degrees by construction. And this line cuts our semicircle at point D. Then we say that the length BD is square root of x. So let's take probably one final example. So say we want to find out, let's make it a little bit different. Let's say we want to find out maybe square root of 16.8. I'm just randomly writing some real numbers here. Say this is what we want to find out. So how are we going to solve this? Well, we are going to draw AB such that AB, the value AB, will be equal to 16.8 on the number line, or the length will be 16.8. Then we are going to extend the point, we are going to extend the line AB to point C such that BC is 1. So BC will be 1. After that, we are going to find the midpoint of the entire line AC, and we call the midpoint O. So AC right now will be how much? AC will be AB, which is 16.8, plus BC, which is 1. So this will be, say, 17.8, right? So now OA or OC will be equal to half of AC. So AC by 2, or 17.8 by 2. Now we are going to draw a semicircle with O as center and OA or OC, this value as radius. So how much is this value? Well, this value simply is, so 2 8s are 16, right? So 1 and 9. So 8.9, right? So now we are going to draw a semicircle that will look something like this. After that, we are going to draw a line perpendicular passing through B and perpendicular to AC, and that line will intersect or cut the semicircle. Let's call it point D. And then the length BD will be 16.8. So two things actually come out from this conversation. First, we now have the measure of square root of any real number. So how do we take this length and put it on the number line? And the second question, which is more important, is why does this method work? We are going to address both these questions in the next couple of videos.